Math 100 Lesson 5-7 covers negative exponents and scientific notation. So I just want to remind us of a rule that we've already gone over. It will be useful. Remember, if we are dividing and our bases are the same, then we subtract our exponents. So up until now, every time we subtract our exponents, we've ended up with a positive exponent answer. For example, x to the 6th divided by x squared. We have so far been getting answers that look like this, that have a positive exponent. Now we're going to start working problems that do not get a positive exponent for the answer, and then we've got to know what to do with that. So we still subtract the top exponent minus the bottom exponent. And so I end up with x to the negative 2. So we've got to know what to do with that, since it's a negative exponent. Well, there is a rule for that. Our rule for this is if you get some number raised to an negative exponent, then that means put that thing in the denominator and the exponent becomes positive. Now this 1 didn't just come out of nowhere. We think of it as our coefficient that is sitting in front of this b that we don't have to write because it's a 1. That coefficient is the number that is sitting right there. So I didn't just come up with a 1 out of nowhere. So this particular answer would be 1 over x squared. And that's how we would write that. We can never leave a negative exponent in our final answer. My math lab will count it wrong if you do that. So let's try a few problems. If I gave you no variables, we just have numbers. So 4 to the negative 3 means 1 over 4 cubed. Now I can actually do 4 cubed. That's 4 times 4 times 4, which is 64. Now if I have a negative 3 and I raise it to the negative 2, let's first take care of the negative exponent. So when I put negative 3 in the denominator, my exponent is the only thing that changes sign. The negative in front of the 3 stays there. And negative 3 squared is positive 9. So we get 1 over 9. Now this same problem, well, it appears to be the same problem, but it is not. Notice that in the one that I just wrote, there are no parentheses. So the way that I see this problem matters. Technically, what this says is negative 1 times 3 to the negative 2. That's what this problem really says. So if I think of it like that, which is the way that we have to think about it, 3 to the negative 2 is 1 over 3 squared, which would give me 1 over 9. And now when I multiply that by negative 1, I get negative 1/9. So that would be my answer there. So being careful with if there are parentheses, if there are not parentheses. Now, I gave you this rule that said, okay, that means we can put it in the denominator and the exponent becomes positive. But what if it's already in the denominator with a negative exponent? Well, if that's the case, it gets moved to the numerator, right? And so it becomes b to the n. So if we practice that with just some numbers, all right. So this one's a little crazy. I've got negative exponents in the numerator and denominator. To make my negative 3 a positive exponent, it has to go to the denominator. To make my negative 2 a positive exponent, it has to come to the numerator. And now I do what both of those say. 5 squared is 25, and 4 cubed is 64. All right, paying attention again to our parentheses. All right. Now, when we see this, we have a fraction raised to a negative exponent. So that means we're going to put the whole fraction in the denominator. There's an easier way. If you flip the fraction over, our exponent becomes positive. And now we do what it says. So 4 squared over 3 squared gives me 16 over 9. Okay, if I have 1 over 4x to the negative 3. Now, being careful here, that negative 3 is an exponent, but is only the exponent to the x. So when I move it to the numerator, the x cubed definitely moves to the numerator, but that 4 stays in the denominator because it was not raised to the negative 3. So being careful when you look at your problems. Okay, on this one, our x has a negative exponent, so to make it positive, it has to go to the denominator. But guess what? That y to the 8th already has a positive, so it's going to stay right where it is. Now, I can't leave a nothing on the top. And so this is where I think about that 1 as my coefficient that was sitting up there that I didn't really pay any attention to. That coefficient is still staying there, the 1. So this would be my solution, 1 over x squared y to the 8th. All right, let's do a few more to add a little bit more stuff to our problem. All right, so if I do this problem like we've been doing when we were dividing our polynomials, I would say 75 divided by 5 times x, and we subtract our exponents. And we do say top exponent minus bottom exponent. So 75 divided by 5 is 15. And when I subtract these exponents, I get negative 6. The exponent is only on the x, so the 15 stays right where it is, and the x to the 6th gets moved to the denominator. So that would be my answer. All right, we're going to treat this one just like the one above. I'm going to start with my coefficients and divide those. And then multiply by. I subtract my exponents, top exponent minus the bottom exponent. So 50 divided by 25 is negative 2. And then 8 minus 14 would give me negative 6. So again, that negative 6 is my exponent, and it's only on the y. So the negative 2 is going to stay right where it is, and y to the 6th goes in the denominator. All right. Let's do one more, and we'll move on. Okay, now I always am thinking mathematically that if I can do order of operations, I'm going to. Right, so the first thing I'm going to do is take care of what's inside, because I can do that. I can do x to the 5th minus x squared, and I get x cubed. Okay, because the 5 minus 2 gives me x cubed. Now, I still have the negative 3 outside. A power raised to a power, I get x to the negative 9. And then, it has a negative exponent, so it must go in the denominator. So 1 over x to the 9th. Right, so that's all that we're going to talk about with our negative exponents. Let's move on to scientific notation. Now, this may be something that maybe you never really understood, or maybe you were excellent at it. We're going to look at it again. All right, so scientific notation is a number that is in this form. All right, a times 10 to the nth power. And our a value is always some number between 1 and 10. Now, it can equal 1, but it has to be less than 10. That's what that says right there. I should have an n for that exponent. All right, so a times 10 to the nth power, and that is a number in scientific notation. So if I took the number If I took the number 2.6 and I multiplied it times 10 to the 7th, well, this is scientific notation, right? If I want to change it into standard form, so if I said, okay, write this number in standard form, well, that's the way that we're used to seeing a number, is in standard form. So that 10 to the 7th, that means we are going to move the decimal 7 spaces, I should say spaces, to the right. Now, we chose to go to the right because 7 is a positive number. All right, so we're moving the decimal 7 spaces to the right. Currently, my decimal is sitting right here. So I'm going to move it 1, 2, 3, 4, 5, 6, 7 spaces to the right, and that's where my new decimal will be located. Everywhere there's a space, I put a 0. So when I rewrite this number, because that's ugly, we need to put commas where they belong. So when you're writing a number, go backwards here, I get a comma there and a comma there. So this would be 26 million. That's how we would write that number in standard form. 2.6 times 10 to the 7th is 26 million. Okay. Let's try another one. We're still going to write this number in standard form. If I have 1.1 times 10 to the negative 4. All right, this time the decimal moves 4 to the left because it was a negative value. All right, so I've got my number 1.1. My decimal's currently here. I'm going to the left 1, 2, 3, 4, and that's where my new decimal is located. So these blanks get zeros. You cannot leave your answer like that. It appears to have 2 decimals, which is not true. So we have 0.00011. Now, if you want to stick a 0 in the front of that decimal, you can. It doesn't change the value if you don't. All right, so those are 2 examples of going from scientific to standard. Now let's go from standard to scientific. So let's take this large number, 4,600,000, and we're going to write it in scientific notation. I abbreviated there a little. All right, so we're going to write 4,600,000 in scientific notation. Well, remember I told you that scientific notation is a times 10 to the n. And this a value has to be between 0 I don't think I said 0. I think I said 1. It has to be between 1 and 10. Yeah, it has to be between 1 and 10. All right. So what that means is that I've got to move the decimal. Currently, our decimal is sitting right here. Okay, when you have a normal number, it's sitting at the end if you don't see it. Well, I'm going to move it all the way over here so that this becomes 4.6. All right, now I moved it way over there. If I wanted to express this as scientific and make sure that I can go back and forth, this would be 10 to the, I move it 1, 2, 3. Let me change a different color and show you as I'm counting. Okay, it is here, which is 1, 2, 3, 4, 5, 6 spaces from where it originally was. Now, you can double check yourself and just make sure if you wrote scientific into standard, we would move this decimal 6 spaces to the right, which would put us back where we started. So this would be our scientific notation. All right, let's say I start with a really small number, and we're going to write that in scientific notation. Well, this time, I want that decimal, it's currently, you can see it, and I want to move it all the way to right there, between the 2 and the 3. That way it makes it bigger than 1, less than 10. So this would become 2.3 times 10. Now, I moved it over here to the right. However, when you write it in scientific notation, if I wanted to move it back so that you know the standard position, I'm moving it left. And how many spaces am I moving it? 1, 2, 3, 4, 5 spaces. So 2.3 times 10 to the negative 5 would be our answer there. Now, we can do all sorts of things with scientific notation. We can multiply them, divide them, raise them to a power, but it's not too difficult to do that. So if I have some number that is in scientific notation and some other number that is in scientific notation also, and we're multiplying those two scientific notation numbers, all I have to do is multiply the numbers that are out front, the a times b, okay, that gives me a number, and then times 10 to the, and add our exponents. Okay, so for example, if I have 4 times 10 to the 5th, that is a 5. Times 2 times 10 to the 9th. All right, so this would be an example of this problem. So we're going to multiply 4 times 2 times 10 to the 5 plus 9, which gives me 8 times 10 to the 14. Now, this is my answer. I do need to just double check and make sure that this number here is between 1 and 10. And mine is, so it is okay to leave my answer this way. So there's an example of multiplying. Let's do another one. Okay, now we are going to divide. All right, so for dividing two scientific notation numbers, you would start by dividing just the a divided by b, and then you would multiply by 10 to the, and this time we subtract the exponents since we are dividing. So let's do an example of what that would look like. Okay, so two scientific notation numbers and we are dividing. So we're going to say 1.2 divided by 4.8 times 10 to the 6 minus negative 3. Top exponent minus bottom exponent. Okay, now need to simplify that. So 1.2 divided by 4.8. All right. Now some of you may need a little extra help with this. So I'm going to do it off to the side over here. 1.2 divided by 4.8. If I move this decimal to the right once, then I do the same thing here. And I get 12 over 48. Now I know 12 goes into itself once and it goes into 48 4 times. So this is really the fraction 1/4. So 1.2 divided by 4.8 is 1/4 times 10 to the, and you've got this little minus negative. Remember, we changed that to a plus, so this would be a 9. Now, a little bit of a problem here. Remember, I said that we had to, once we get our answer, we need to double check and make sure that this number that's sitting in the front is between 1 and 10. And 1/4 is the decimal 0.25. Okay, so we've got a problem, all right? It is not bigger than 1, and that's not okay. Okay, so we have to change that. Okay, 0.25 is not bigger than 1. So I want to move that decimal one place to the right. Well, if I move it one place to the right, then this exponent changes okay? Another way I can think about it would be, let's just say I took this and wrote it in scientific notation. Well, that would be 2.5 times 10 to the -1. Now, you still have this 10 to the 9 sitting out here. Didn't do anything with that. And now I can multiply. Right here I have the same, I have like terms here, so I have 10 to the -1 times 10 to the 9 would give me 10 to the 8. So this is the correct answer, completely simplified. One more idea with scientific notation. You can have a number that is in scientific notation raised to a power. And so that just means you will raise everything inside to that power. Power raised to a power, we multiply. So that's why that says 10 to the mn. So an example there would be 5 times 10 to the -4. And I want to raise all of that to the third power. So 5 to the third power times 10 to the -4 times 3. Okay, now I can do 5 cubed. It's 5 times 5 times 5 is 125. 10 to the -12. All right, this is bigger than 10. Okay, that's not okay. It's 10 or bigger. That is not okay. So we're going to write this in scientific notation, 1.25 times 10 to the second power. And I still have this 10 to the -12 out here. So I multiply and add those two exponents to get 10 to the -10. So that would be my answer. All right, so that is all of scientific notation. Hopefully that's not too much of a struggle. I hope to see you in a Teams meeting. If you have any questions, you are welcome to email me. Please don't forget to be showing your work on paper. Good practice for when we take our test.